The departments of geology and geography at the University of Alabama are involved in very impactful and interesting research within the natural sciences. Climate is a research focus for both departments.
Here at the University of Alabama and the Department of Geological Sciences, our core research areas are traditional geology, energy, and the environment. We bring those three together to look at energy, sustainability, and environmental impacts.
There's a great deal we can learn about past climate change by looking at archaeological remains. In this lab, we focus on microsampling the organisms that humans ate in the past. The chemistry of organism skeletons often reflects the environment in which they grew. So in essence, each one of these shells can serve as a black box to sort of untangle past environmental variation at a human scale. If we can better understand how people coped or failed to cope with climate change in the past, then maybe it'll give us some clues to how we can behave in the future in ways that are useful to us.
One of the projects that we're particularly proud of is a Department of Energy funded geological carbon sequestration project. Here we're looking at the feasibility of taking CO2 out of the flue gases of coal-fired power plants and injecting that into the subsurface.
We need to get carbon dioxide that's produced by fossil fuels locked away from the atmosphere, and geologic storage is one of those options. Even better, though, if we can not only sequester the carbon dioxide, but also utilize it for a beneficial purpose. Enhanced oil recovery is a method of getting as much oil as possible out of existing reservoirs.
We're using a range of techniques, geophysical techniques to image the subsurface down to many miles.
My part of this project is to understand the geochemical reactions that will take place as a result of the injection of CO2, because we can have good reactions that will increase the permeability of the rock and enhance the recovery of oil, and we can have adverse reactions where some new minerals may precipitate in the rock and plug up some of that permeability.
The Department of Geography at the University of Alabama is one of the oldest geography departments in the nation. It was established in 1903. We're very proud of that rich history, but we're currently in the process of reinventing our department to make it one of the more progressive programs in the country.
As a geographer, I'm studying how people perceive, interpret, and react to weather information, and how accurate public perception is of that information. Although forecasting technology continues to improve, and it probably will continue into the future, that improvement in technology and greater lead times for warnings and greater forecasting ability, it means little if people are not correctly interpreting the information and understanding their true risk assessment. My research in particular, so far I've been looking at sheltering behavior and sheltering decisions, and it usually takes some type of large magnitude event where people will change their minds for what they're going to do in the future, and certainly we saw this in Tuscaloosa.
In addition to Jason's work with tornadoes, we also have research being conducted by myself and Dr. Justin Hart into some of the indirect impacts of tornadoes. For example, in river systems that I work in, once tornadoes have occurred, they introduce huge amounts of what we call coarse woody debris into the stream channels due to all of the blown down trees and disturbance created by them. And so these types of changes can change the water temperature for long periods of time because it reduces the shade cover, and this has the potential to create loss of ecological function in the streams.
In our research group, we place a major emphasis on understanding the impacts of disturbances such as fires, floods, tornadoes, ice storms on forest development and successional pathways. So the impacts of those disturbances on forest ecosystems can be influences on forest regeneration patterns, species diversity, the arrangement of biomass or tree age distributions. And those impacts can be evident for years to decades to centuries.
I'm currently working on a new model or an enhancement of my global sediment flux model to allow us to predict floods in the near future and also in real time. So it's using both remote sensing products and numerical modeling in high-performance computer clusters, supercomputers, and so on, to predict when floods will occur.
These particular types of research topics are meaningful and have great potential for helping society adapt to climate change and natural hazards in general in the future.